In this video, we're going to talk about example 14.4 from our textbook, changing the margin of error. And what we're going to do is kind of continue this using the same information that we had been talking about in 14.3 and in earlier problems, where we're looking at those, the tip messages, the good weather, bad weather, no weather, that were left on the bills of 20 patrons, 20 for each, and kind of comparing what's going on with those. And what we're going to do is explore what happens when we change the confidence level, what happens to the margin of error as the confidence level is changed. So we know from our previous problem, the previous example 14.3 that we did with this problem, that when we have a confidence level of 95%, our confidence interval was 22.21 plus or minus 0.88. So that's what a confidence level of 95% would look like. So now what we want to do is we would like to calculate, using the same data, a confidence level of 90% to see what ends up happening to our confidence interval, and in more specifically what happens to the margin of error. So we're going to use our formula. The sample of the mean is our estimate for the sample of the population, plus or minus the z-statistic that accompanies our confidence level, times the standard deviation of the population divided by the square root of n. And as we looked at that information before, writing down our data here, we don't know what the population mean is. That's what we're trying to estimate. We have the standard deviation of the population, which was 2. Our n, we had 20 patrons in the sample. Our x bar we were given was 22.21. And the standard deviation of the sample we don't really need to calculate, because as we talked about in the last example, that's built into the formula now at this point. So the only piece of information that we're missing from this formula is this z-statistic. So what we need to do is go back to table C in our book and find out what is the z-statistic for a 90% confidence level. And again, what that's going to give us is how many standard deviations away from the mean, plus and minus, will contain 90% of the sample means in that distribution. So when we look back, our z-statistic for 90% is 1.645. So now we have all of the information to be able to plug into our formula. So we have 22.21 plus or minus our 1.645 times 2 over the square root of 20. And when we do this out, we get 22.21 plus or minus 0.74. So you'll notice now as we've done this, when we go from a confidence level of 95% to a confidence level of 90%, so you know what we're doing here, again, the confidence level is the probability that this confidence interval, that this range of values will contain the population mean. So what we've done by going from a confidence level of 95% to a confidence level of 90% is narrowed our bucket. You know, if we are less sure, that if there's a lesser probability that the population mean is going to fall within that area, then the range of values naturally is going to be smaller. So if we look at this, you know, thinking this graphically on our distribution, if we have a 95%, here's our mean. If we have a 95% confidence interval, which is 2 standard deviations away from the mean, so everything in here, there's a 95% probability that our population mean falls within this bucket. However, our 90% is a smaller confidence level. we're not as confident that it's going to be in the bucket. And the reason that we're not as confident that it's going to fall in that bucket is because the area is much smaller. You know, this is only just over 1.5 standard deviations away from the mean. So our 90% confidence interval is only going to be in this yellow area. So as your confidence level decreases, your margin of error also decreases, because you're now looking at a smaller interval to contain the values that you're looking at.